This video should give you a short review on linear regression. The reason that we need to remember how to do linear regression is because Chapter 15 is now going to have us do hypothesis tests and confidence intervals for slope. So let's look at this example. We're going to decide if there's a relationship between square footage of a house and its price in dollars. So the first thing that we want to do is enter this information into our graphing calculators. So we want to press Stat, Edit, and put our x values in L1 and our y values in L2. Once you have all your data in your calculator, press second y equals and go into the first graph. We want to make a scatter plot because this is bivariate data. So make sure that this graph is turned on. Select the scatter plot. And then for X list and Y list, our data is in L1 and L2. You can choose any of the marks that you would like. Then press zoom 9, so the calculator will pick a window for you that will let you see your data. So we can see that we do seem to have a roughly linear pattern with a positive slope. Now let's see what the actual numbers say. So press Stat and go over to Calc and choose number 8, Lin Reg. You want A plus BX because that's how statistics books will show the formula. Now we need to make sure our calculator knows where our data is stored. So we want to add to that L1, L2, and now we're going to add Y1 so that it will put our linear equation in Y1 and graph it. So press the Variables button, go to Y Variables, choose Function, Y1, and now press Enter. Now if we go back to our graph, it would look like this here and show our equation. Now notice here we have our slope as B and our y-intercept as A. And we also have R squared and R. When you go to write your linear equation, remember that you must use y hat and then plug in your A and your B and define your x and your y. Remember the R is correlation and the R squared value is the coefficient of determination. Now you can get the same information from a computer printout, and the AP exam will often show these printouts for you to interpret. And so you want to look at two areas, right here and right here. Now this printout does give us the equation, but in most cases they will cover that up so that you have to look for it yourself. So under coefficient, the first number will be the A, the constant, and the second number is our B, our slope. And then this number here, this is our R squared as a percentage. To get the R value, you would move your decimal over twice to the left and then take the square root. Remember how to interpret the R and the R squared. Your correlation of 0.762 is moderately strong and positive. That shows that our graph has a decent linear relationship. Remember that anything close to 1 or -1 is strong, and as you get closer and closer to 0, that gets weaker and weaker. The R squared is interpreted as 58.1% of the variation in house prices. Our Y variable is explained by its linear relationship with square footage, our X variable. Now the last thing we need to remember how to do is make a residual plot. Remember that residuals give us the error for each point. They are calculated by doing the observed Y minus the predicted Y. The observed Y comes from the table. The predicted Y comes from plugging X into your regression equation and solving for the Y hat. When you look at your residual plot, you do not want to see a pattern. No pattern indicates that a linear model was a good fit for our data. So go back to your calculator, and the calculator will actually calculate the residuals for you. Press Stat, Edit, and go over to L3. Make sure that your cursor is highlighting the L3, and press second Stat, and look for resid. In my case, it's number 8. So you should see resid right here, L resid. Now press enter, and the calculator has done your residuals for you. Now, in order for the calculator to do this, you must have stored your regression equation in Y1. Now that we have these values, we can graph them. So press second y equals, go back into your scatter plot, and change the Y list to L3, where you stored your residuals. And then press zoom 9. And our residual plot doesn't seem to have a pattern, which indicates that a linear model was a good fit for our data.